Alright, let's finish this two projects.
Assignment. In the markdown, we have to make a draw line plot, a draw bar plot, and a draw box plot. And these are the figures inside the examples. Right here, figure 1, it's just a line plot. Figure 2, it's a bar plot. And figure 3 is the box plots. And it's using the free code camp forum page views data. So in this line graph, it's saying page views and then the date. And over the years, we see that the page views have been increasing. And there has been spikes and dips as well. So yeah, let's get started. We can basically just put all of our code in the time series visualizer.py. And first we have to import the data, make sure to parse the date and set the index column to date. And we can actually do this with just one line. We read the CSV, free code camp forum page view CSV, so this one, and we parse the dates equaling the date, and then index column.
So parse dates. I think it's just a method. It's not. I don't think it's a part of Python language. It's just the way that you have to design this pd.read CSV when you pass more parameters. Maybe not. Just gonna show search for the parameters. Oh, it's Pandas, right? Not Python. Oh, it is Python, but the Pandas library that I want here. Maybe I should read all of this as well at some point. Not all of it, but just the relevant parts that I think are relevant. I'm gonna watch a video and then if I can't find the answer, I'm gonna read the documentation.
Hey there, how's it going, everybody? In this video, we're going to be looking at how to read, parse, and write CSV files. Now, if you don't know what CSV files are, it stands for comma-separated values. Basically, CSV files allow us to put into a plain text file some data and use some type of delimiter, usually a comma, to separate the different fields. Now, I have a sample CSV file here that we can work with, and if we look at this, then we can see how these are usually structured. So this can kind of look like a mess, but it's not really meant to be read directly. This is just how the data is stored, and then we can use our programs to parse out the information that we want. But we can see that the top line here has our fields. Now, our fields in this file are first name, last name, and email. So that tells us the information that we should expect to see on every line. So if I go to the next line here, then we can see that John is the first name and then a comma, Doe is the last name and then a comma, and then this long email here is the email. So that's why these are called comma-separated values. And what separates the values is called a delimiter. So the comma is a common delimiter, but you can use just about anything. So sometimes you'll see files with tab delimited values or dashes or things like that, but they're all called CSV files. So now let's see what it's like to read, parse, and write to CSV files. So I have a file here called parse.csv.py, and within this file, we're just going to import CSV. Now you may have looked at that data. CSV module has a CSV file. So to read this file, something complicated from scratch. Okay, so to read this CSV file, we're just going to open this file just like any other file. So we'll use a context manager here, and we'll say with open, and the name of that file that I was just looking at is names.csv, and it's in the same directory as the file that I'm currently writing. And we want to read this file, so we'll put an R there as the second value. And now what we want to call this, so we'll say CSV file. So to read this file, we can say CSV reader, and that can be any variable name that you like, but that's what I like. And then we can say CSV, and then use this reader method, and then pass that CSV file into that reader method. Now in the background, that reader method is using something called a dialect that has some preset parameters for what it expects the format of our CSV file to be. So by default, it's expecting values to be separated by a comma and a few other things that we'll look at in just a bit. But since our CSV file is pretty simple, we don't need to pass any here. So each line that we're printing out, we only wanted to print out all of the top. Now we can CSV. We want to open this for writing, so the second a dash module, 2 is for the delimiter. Now variable, and we're using this writer method of the CSV module to open up a writer using that new file with a delimiter of a dash, and then for each line in this original CSV data, we are writing out to the new file each line of the original file. So now if we run this, then we don't have any output here. Our CSV can be represented with this tab delimiter, and just tried to pass in that we want reader like this is because it makes it a lot. So I'm going to method where instead field names in the first row. So if we want
I wish they showed examples here. So this uses the first column as the index. When you set it to true, apparently. This lambda thing is something that I've seen so far as well, a couple of times. Date time handling, parse dates, boolean or list of ints or names or lists, of lists or the default false. If true, try parsing the index. So it is a method from Pandas. If 1, 2, 3, try parsing columns. 1, 2, 3 each has a separate date column. If full, 1, 3 parse columns. 1, 3 as date and call result full. A fast path exists for ISO this number. Is true and parse dates. The name for a column, temperature for the datetime format to speed up the processing. This is the one that he's using, I think. No, it's the other way. Parse. Yeah, he's using this one then. So this is to parse the date, and then index column is to parse the first column. I think I understand now. So
column equals date. So that's how we set the index column to date, just by putting it in there. And to see all these different options that we have for this Read CSV, just look up Pandas Read CSV, and yeah, and then we can see their documentation, and there's all of these different options, and it kind of explains what they do. So index column, this is the one we used, and we also used parse dates. And parse dates, we have date parser, and parse dates right here. So yeah, this kind of explains it. It's still pretty confusing though, but what do you do? Clean data. This is kind of what we did in the one before this. We used the Quantile thing to get the data in between the top 2.5 and the bottom 2.5. So we can just do that with this. With this, we grab our data frame, and then we do the different quantiles for the value. Next up, we have to draw the line plot, and we're actually just going to use matplotlib for this one. We're not even going to use Seaborn. And to make our figure and our axes, we're going to do matplotlib, which is PLT as.
So he did the same way. He used Quantile, which I don't know what it is. But it's pretty similar to the other video I watched from the guy of filtering using these Boolean statements. I'm gonna search for what's Quantile after copy this.
StatQuest is special. Yes, it is. StatQuest. Hello, I'm Josh Starmer, and welcome to StatQuest. StatQuest is brought to you by the friendly folks in the genetics department at the University of North Carolina at Chapel Hill. Today we're going to be talking about quantiles and percentiles, and they're going to be clearly explained. I thought putting this StatQuest together was going to be super easy, but doing a little research sent me down a crazy rabbit hole. Pretty much every web page I looked at had a slightly different explanation. Part of the problem is that there's a difference between how the word quantile is defined and how quantiles are used in practice. The other problem is that there's a ton of different ways to calculate quantiles. The quantile function in R alone has 9 different methods. Let's start by talking about the strict definition of quantile, and then we'll move on and talk about how the word is used in practice. If you can recognize the definition, you can skip it and move on to something more useful. We'll start by measuring expression for a gene. Then we measure expression for another gene. We measured expression for sometimes this quantile, the median, is labeled 0.5, since it splits the data in half, and sometimes it's labeled 50%, since 50% of the data is above it and 50% is below it. The median value is 4.5. Thus, the 50%, or 0.5 quantile value is 4.5. To summarize this first point, the points are less than it. Used when we divide files in percentile change a lot from method to method and
हेलो एवरीवन, इस वीडियो में हम बात करने वाले हैं स्टैटिस्टिकल टर्म क्वांटाइल की। अभी तक हम इन सारे टर्म्स को डिस्कस कर चुके हैं। यदि आपने मेरी प्रीवियस वीडियोस नहीं देखी है तो आने के लिए हम इसको पहले
I hate when they
की
put
आंसर
the
शीट्स हैं।
title in English and the videos in a different language.
Hello everyone, let's look at how you can interpret a simple quantile plot and how it's implemented from scratch in Pandas. So let's get started. A QQ plot is a scatter plot created by plotting two sets of quantiles against one another. If both sets of quantiles came from the same distribution, we should see the points forming a line that's roughly straight. The procedure to draw QQ plot for all the above applications are the same. I'll explain the most common use of QQ plot, that is, to check if my sample data is from a normal distribution. Most of the parametric tools and statistics work with the assumption that the sample data is drawn from a normal distribution. So in order to rely on the results of those tools, it is necessary to be confident about the sample data distribution. Let's start by reading the data from a CSV file after importing our necessary modules. I want to check if the points column in my data frame DF is normally distributed. The first thing that I'll do is I'll arrange the points column data in ascending order. Next, I'll divide. We have I run the corresponding for each.
Hey guys, good morning and welcome back to a brand new video. My name is Aditya Aurange and in this video we're going to learn about quantiles and quartile. So quantile is any value which divides the dataset into a particular manner. So before that, let's think about percentile. So you have seen percentile are used for ranking. Okay, so in competitive exam we use percentile for ranking. So for 90 percentile means 90% of the students fall below this student which has 90th percentile and 10% of the students are above him, ranks above him. Okay, so similarly 60th percentile means 60% of the total students are below him and 40% of the total students are above him in ranking. Okay, so in quantile we don't have 50th, 60th, we have 0.5, 0.6, so both means the same. So if we are given like find quantile at 0.5, so that is a value which divides the data set into equal parts. So 50% of the values will lie below it and 50% of the values will lie above it. So the data set is first arranged in ascending order. So that's how 50% of the values, smaller values to that value lies to the left of it, below it, and 50% of the values which are greater than it lies to the right of it. So same way if you are given find quantile at 0.3, that means that value will have the data set divided into two parts. So to that left of that value, 30% of the values will be there which are smaller than that value, and to the right of which that value there will be 70% of the total values which are greater than that value, quantile value. So total there are 10 values. So let's say if I want to find quantile at 0.5, so value will divide the data set into equal parts. So I have intentionally taken the values in ascending order so it will be easier for you to understand. So first step is arrange the data in ascending order. If you want to find it on pen and paper, arrange the data in ascending order, that's the first step. Second is count the number of elements, so n you will have. So here the n is 10 values are there. And third step is find the value or the n plus 1 within brackets. So first do n plus 1 and then multiply it with q. So like you are given 0.4, quantile at 0.4. So that quantile value into n plus 1. So I have here 10 values, so 10 plus 1 which is 11. So quantile into n plus 1. So 4.4th element is my quantile value at 0.4. So I have 4th value and 5th value. I don't have 4.4th value. So how we can find it? There are multiple ways. So one way is to find it on pen and paper. One way is to 5th value minus 4th value. Okay, 5th value minus 4th value. So what is 5th value? 15 is my 5th value. So 15 minus 14. If I do this, I will get my quantile value at 0.4, which is 14.4. Okay, so this is another way. But the function used here in data frame quantile function doesn't give value according to any of these. Okay, first method was rounding it and using that rounded value which is fourth element straight forward. Second is 4 into n plus 1. So n plus 1, 11. I had to find at 0.2. Okay, so I get 12.8. So
I think I'll keep doing the solution. Get
It's
this
imported.
later.
plt, and we're going to do subplots and make a figure size. It's going to be a rectangle, 10 of width, 5 of height, and then we can add on to our axis some different properties. So we'll do ax.plot, and df.index grabs our date because we set our index column as date. So that grabs the date, and that will be the x value, so on the x-axis. And then the second parameter is the y value, so that one is going to be the series of value. And then the third parameter is going to be r, which stands for red. It just means make a red line. And we can like have red dashed if we do like red dash dash, but we just want it to be red. And we're gonna also set a line width equal to 1. And we're getting a error here because I have to do figure size equals 10 and 5. And then these next 3 lines are pretty simple. We just have to name our different parts of the graph. So our title is gonna be this, daily free code camp forum page views. And we have a set X label of date and set Y label of page views. That's it for that. We can save the figure as lineplot.png, and it should look something like this, except it will look a little bit different. If we don't want any of these errors, I'm pretty sure we can just do figure equals plt.subplots, and same with this one. And then that should get the errors away, and then we can try running it and see if this line plot is correct. Again, it takes a while to download and install all of the dependencies. For me, it takes about like 3 to 5 minutes, I would say. All right, there we go. It ran it, and we get our lineplot.png, and it looks like this. Not exactly the same as this one, but it is pretty similar. They kind of have a darker red line though, and it's also a like wider image compared to ours, but it still passes the line plot test. So next up, we have to draw the bar plot, which is supposed to look something like this, average page views, and then it has the different months as well. And we kind of have to change the data a little bit for this to work. So we'll go back here, draw a bar plot, and I think because we parsed the dates, we can actually do this pretty easily. This is how we get our different series. So we have our month series and a year series now, and that's just index.month and index.year. So that's the date, and then we grab the month off the date and the year off the date, and we put them into their own series. And then we grab their values and we average them out, looks like. So over this month of February, so this orange line, or it's December, yeah, it's December, what were the average views per day in that month? And we can see that it's all the way up here. So that's why we need that. And then we df_bar.unstack for some reason. I don't really know. And now we can draw our bar plot, and we can do
Just gonna copy that.
this with df_bar.plot. So we can actually just plot a pandas series. So if we go to pandas plot, yeah, we can just do a data frame.plot, and then it will actually use matplotlib like on the back end to make it. So it's kind of using like, it's kind of like using matplotlib, except the API is a little different, like the different parameters that we set in is a little different. So we have our X and Y, but what we actually need is, no, this is just plot. We do plot.bar. Here we can set a kind of bar, but we can actually take it one step further inside of here and do dataframe.plot.bar. If I can find that. So yeah, here's the dataframe.plot.bar. Seems like it takes in a bunch of the arguments documented in dataframe.plot, but it also has a color and then the X and Y position. So yeah, so dfbar.plot.bar. We want our legend So we're going to do legend equals true. We're going to have a figure size equal to a rectangle, which is like 10 and 5. We're going to have a Y label equal to average page views, and we're going to have a X label equal to years, and then we're going to do dot figure on that. So I'm guessing that just makes it into a figure. And then we can actually change our legend up by doing PLT, and PLT is like the global matplotlib figure. That's what we import here, and we can just like set the legend on this, and the legend is going to be January, February, all the months of the year. If we didn't have this, then it would just be numbers 1 through 12, which we don't want. We actually want the different names of the months. We can also set font sizes of the ticks. We can set the X ticks font size of 10, Y ticks font size of 10. I don't know if this really matters, so maybe I'll change Y ticks to 20 and see what it looks like. And then yeah, we just save the figure and it will show up as barplot.png. So let's try running this. Here's our barplot.png right here. So yeah, looks like our Y ticks are pretty big, but it does look pretty similar to figure 2. So yeah, if we want, we can change some of this stuff. Say we want our figure size to be actually like 13 and 6 or something, I don't know. And then font size to be actually like 8 and 8, so really small, and run it. Then it will just change the same bar plots, and there it changed it, and we have our average page view and our years, and it looks like this. Now we have to draw the box plot, and we actually get to use Seaborn for this one, and they did this for us, which is cool. First thing we have to do is this in front of our subplots. We need a month number on this data frame that grabs our date and then the date, time, and month, and then we sort the values of the month. So now those values are sorted, then we can grab our figure and our axes. Since we have two different plots here, right, we have this one on the left and the one on the right. One's the year-wise and one's the month-wise. This is where this comes in handy. So the figure is like the whole figure. Axes is the different graphs on it. We can specify that we want rows of 1 and 2 columns. So we do n columns equaling 2, and then we set our figure size equaling 10.5, so just a regular rectangle. And then we can change the different attributes of these graphs using axes, and then we set the index of them. So axes of 0, that would be the first one, so the one on the left. So this would be the year-wise plot, and we need to change it so that, or we actually have to make it first of all. You have to go sns.boxplot. So Seaborn has a boxplot function where we can just pass in the x and y data. So x is the data frame box year, and then y is the df box value. And then we just specify that the axis this is on is axis 0. And then we kind of do the same thing for the second one. This one's going to be axes of index 1, and then we're going to pass in the month this time instead. And then the last few things in this is pretty easy. It's just setting the title and the different labels on it. So we set the title, year-wise box plot, X label year, Y label page views, and then the same for the second one. And then we save it. And then it should run, and it should look pretty beautiful. So there we go. We have our box plot. Looks like this. Oh yeah, I ran 11 tests, and one of them failed. And it's kind of a weird error. I'll show you how to fix it. But yeah, I'm going to try getting
Probably have to look at this again eventually, because since I'm copying, I'm not learning as much. It's just a matter of reference, really, in my mind. because as long as you stick with it and you're consistent, eventually you're gonna learn. So I think it's more about figuring out the best way to be as consistent as you possibly can. And I think the best way so far for me is that I found is that sometimes I try to do it by myself, and then sometimes I just copy. That way, I think is a nice mix between where I'm not gonna get stuck on tutorial purgatory, but at the same time, it's not so difficult that I just don't want to do it that often. Just searching for things is really boring all the time. And frustrating as well.
Rid of this and see what happens. See if we actually need those two lines. So I'm not exactly sure what they do. Okay, so it's pretty obvious they do something because it didn't pass the test. And I think what they do is it actually just sorts the different dates. So like here it goes May, June, July, August, but in figure 3 it goes January, February, March, April. So that's what that does. It actually just sorts the months of the year so that January comes first. So all right, it's pretty cool. How to fix the error that we get? This converter error, kind of weird. We just go into the test module, and where it says this first one, data cleaning test case, df.count, we can just get rid of numeric only true and instead put index of 0 there, and just keep it as an empty function with the parameters. And now when we run it, it should pass all the tests. Here we go, ran 11 tests and it passed them all correctly. So that's pretty neat. And yeah, this one.
So mine is showing a mistake on fig size. It's saying it's not defined. Oh, he made it equal. He didn't make it equal.
Was a lot like the medical data visualizer, not too much different. We mostly just use matplotlib a little bit more this time though. There's a lot of different ways to make graphs using these libraries and a lot of different ways to do things. So
Another mistake.
I wouldn't be surprised if
Getting a mistake on this PLT X ticket, X and Y tick. Oh, it's a typo. I typed font size wrong, the wrong way.
you guys figured out a different way to do it other than this. Other than that, I will see you guys later. If you like the video, like it, comment down below, subscribe, and I read all the comments, so whatever you put down there, I will be sure to read, and I usually respond to all comments as well. So
So I
right.
got one error, which I
Look
think you talked
pretty
about.
beautiful. So there we go.
So at least that's the way I'm approaching this. Is very similar to the way I approach going to the gym and working out. Is not every day you're gonna have the best workout or go the hardest, because it's not about that. It's about being able to be the most consistent as possible in my mind and not give up, keep coming back. Then eventually you just get better and better. So some days I feel like working harder, so I might try to do it on my own. And other times I still wanna get the exposure for the consistency, but I'm not really. I don't really want to go as hard. So I think this is the best way to do it, in my opinion. That's why I think it really is not that big of a deal to just look at the solution and copy. If you're going to stick with it and you're the type of person that uh, doesn't quit and is gonna keep going, because I feel like the problem is that a lot of people do this but they always do this, and then you'll never improve. Because like that's the same as going to the gym and just never trying to improve or get a PR or something like that. Then you never get better. So for those types of people, then I guess this is bad because they're not gonna work hard. But if you're able to go to the gym and push yourself uh, consistently, then I think it's fine to do every once in a while. Just go easier.
And then the last few things in this is pretty easy. It's just setting the title and the different labels on it. So we set the title, year-wise box plot, X label year, Y label page views, and then the same for the second one. And then we save it. And then it should run and it should look pretty beautiful. So there we go. We have our box plot. Looks like this. Oh yeah, I ran 11 tests and one of them failed. And it's kind of a weird error. I'll show you how to fix it. But yeah, I'm gonna try getting rid of this and see what happens. See if we actually need those two lines. So I'm not exactly sure what they do. Okay, so it's pretty obvious they do something because it didn't pass the test. And I think what they do is it actually just sorts the different dates. So like here it goes May, June, July, August, but in figure 3 it goes January, February, March, April. So that's what that does. It actually just sorts the months of the year so that January comes first. So all right, it's pretty cool. How do you fix the error that we get? This converter error, kind of weird. We just go into the test module and where it says this first one, data cleaning test case, df.count, we can just get rid of numeric only true and instead put index of 0 there.
Change the test. Should work and not actually.
And just keep it as an empty function with the parameters.
But I think the test that is failing is the thing that is this quantile thing. This stuff here that I was searching in the beginning. I'll probably watch the video on that after, and I'm gonna submit the test with one mistake. It's gonna pass anyway. All these projects that they pass, doesn't really matter. You can have an empty link and still will pass. But it's still good to do
And
the exercises I was talking about.
now when we run it, it should pass all the tests. Here we go, ran 11 tests and it passed them all correctly. So that's pretty neat. And yeah, this one was a lot like the medical data visualizer. Not too much different. We mostly just use matplotlib a little bit more this time though. There's a lot of different ways to make graphs using these libraries and a lot of different ways to do things. So I wouldn't be surprised if you guys figured out a different way to do it other than this. Other than that, I will see you guys later. If you like the video, like it, comment down below, subscribe, and I read all the comments.
This next challenge, I'm gonna go directly to the solution from him.
Hello,
I think I'm gonna finish this, then I watch the video on Quantile. On this dude. I'll be right back.
Landon Schlungen, and today
Right,
we are going
back.
to go through the C-level predictor on FreeCodeCamp, and that can be found in the data analysis with Python certification. And then underneath all this stuff, we see the C-level predictor. Just hit that, and then we need to access the full project description and starter code on REPL.it. So just let that load up. All right, and here's our project. It's named Boilerplate C-level predictor, and I kind of want to change that to just C-level predictor 2 because this is my second time doing this, so I can show how to do it. And then just click off, and then it should save. And here's our assignment. We need to import data from EPA C-level.csv, so this data right here. It's all these numbers. And then we have to use matplotlib to make a graph, basically. And we have to like predict how much the sea level will rise through the year 2050. All right, so yeah, we need to make a graph. And we start in the sea level predictor.py. And it's just one function, so it's not really too much to do. They just don't give us like a reference of how it should look. But overall, this one's not too bad. So the first thing we have to do is we have to read from the file. So we do df equals pd.readcsv, and then we get our CSV file. And then we just change y equaling the series of Sistro adjusted sea level, which is actually in here. It's like this second column. So in this case, it would be 0, 0.22, negative 0.44, and so on. And then our x would be the year, and the year is the first one. So we take the first two numbers out of this data set. Now we need to create our scatter plot with matplotlib. And this is pretty easy. We just make our subplots, figure and axis, plt.subplots, which is the matplotlib pyplot. And then we do plt.scatter, and that makes our scatter plot. And we pass in our x variable and our y variable, or the series at least. Next, we have to create the first line of best fit. So yeah, we're going to go from 1880 through 2050. And then for the second one, we're going to just go through the year 2000. So it'd be 2000 through the year 2050. So the first one, this is how we do that. First, we use this linegress function from skippy.stats, or line regress. And we pass in our x and y series. And then we make our x prediction having the years of 1880 through 2050. And the y prediction of this line regress variable dot slope. So this res is actually a object. So maybe I can print that out. It has a slope and it has an intercept, and I think it has a bunch of other things on it too. But yeah, this is just mx plus b, how we make a line in math. We take the slope times x. Yeah, we take our slope times x, and then plus b, which is our y-intercept, and that's what res.intercept is. And then we plot it with matplotlib, and this will just be a line, and we make it red. That's what the R does, it makes it red. So I think I could be able to show this just like it is. I'm just gonna bring this stuff down to add label and titles, because this part's pretty easy. We just set X label, set Y label, and set title. And then I should be able to run it and then see this line of best fit and our scatter plot. And then we'll make the second line of best fit. And then yeah, it takes a little while to update dependencies and stuff. All right, let's run it. It has to install again apparently. All right, there we go, it ran it. We ran 4 tests and had 1 failure, so seems like we got some of it right. So this is what our print res printed out. Line regress result, and then we have a slope, we have intercept, an R value, we have a P value, standard dir or ST dir, intercept, standard deviation. I'm guessing that's standard deviation. Not sure though. But yeah, we also got our sea-level plot.png. So let's take a look at that. And here it is. Here's our scatter plot with the year on the bottom and the sea level in inches. And it looks like it's been rising. And then next up, we have to use just from the year 2000, where it's been rising faster, it looks like. And we have to go through 2050 on that one. So let's do that. Create second line of best fit. It's going to be a lot like this one, except the range is going to be a little different. So here's how we do this one. First, we just grab the data points where the year is.
Make sure I'm getting the same stuff. I'm copying the right way. Okay, so it's very different actually. It's kind of the same actually. Now that I think about it. It's just that all the lines are connected.
Is greater than or equal to 2000.
So I'm doing something wrong here. Oh, I see.
That's what this does. So in our CSV, we only grab the ones after 2000. So that's our new data set. And then we set our new X and our new Y to the year and the Cicero adjusted sea level. And then we do our line graphs, our X prediction, Y prediction, and then plot it. Same as before, just with new values. For the X value, it's just 2000 through 2050 instead of from 1880. And then we put in the slope, our X value, and then our intercept. And we plot it. This time we make it green. Let's try running this. Looks like it still failed, but there's a reason for that. And here's our new graph. And here you can see we have our green line that's shooting up steeper. And that is the line of best fit from 2000 through 2050 if it continued. So yeah, pretty cool there. The reason why this is failing is because the decimal places are a little bit off. At least I'm pretty sure. I mean, these do look pretty dang equal. Not really sure. Maybe it's like this shapes 170, but instead we have 171. Not exactly sure what's going on there. And it says it's for the first line of best fit. So maybe I have to get rid of 1880 and just do 1881? I don't know. I can try it. Oh, so now it says 169, 171 instead of 170. So then let's try 1879 and try that. But now this is off by 1. So it's got to be 1880. And maybe I just have to extend the 2050 to 2051. Yeah, I just played with this a little bit more. It turns out that that one failure was on the second line, and all we had to do was change the second line to be 51 as the same as this first one, which is also 51. And then it runs all the tests correctly. So if I run this, all the tests should pass. Overall, this project was not too bad. Just this little bit of code here. And it's actually relatively easier to understand, in my opinion. Next up, so we got done with the sea level predictor, which is the last one for the data analysis with Python. So we're going on to information security certification. And this first part, you guys can just do on your own. It's not there. And it says it's for the first line of best fit. So maybe I have to get rid of 1880 and just do 1881? I don't know. I can try it. Oh, so now it says 169, 171 instead of 170. So then let's try 1879 and try that. But now this is off by 1. So it's got to be 1880. And maybe I just have to extend the 2050 to 2051. Yeah, I just played with this a little bit more. It turns out that that one...
So it's 2051. What's that?
Failure was on the second line, and all we had to do was change the second line to be 51 as the same as this first one, which is also 51. And then it runs all the tests correctly. So if I run this, all the tests should pass. Overall, this project was not too bad. Just this little bit of code here. And it's actually relatively easier to understand, in my opinion. Next up, so we got done with the sea level predictor, which is the last one for the data analysis with Python. So we're going on to information security certification. And this first part, you guys can just do on your own. It's not too bad. And then we have this Python penetration testing, which is actually just a bunch of videos to watch. And I did not really understand all of it, so the next thing we have is the stock price checker. And the stock price checker has to do something like this, where we can get a price of, say, like Tesla, get their price, and then it returns their price, real-time price, and how many likes they have. It's kind of neat. I can try getting First Majestic with AG. That's 16.32. But yeah, this is what we're going to be building in the next installment. Anyways, if you liked the video, give it a like. Comment down below if you have any questions. I read all the comments.
वन टाइम ठीक है स्टैटिस्टिक की ये टर्म है पहले हो सकता है आपने नहीं सुनो
Yeah, I'm gonna close this video, this stream, and then I'm gonna restart and start this section here and watch this video. So see you soon. Actually, I think I'm gonna watch this video off stream, and then when I come back, I'm gonna do this section here. So see ya.